Hi, welcome to the physics class. Today we will derive an expression for angular momentum. The abbreviation is nothing but L. In order to derive an expression for angular momentum, consider a rigid body like this. So what is a rigid body? Consider a scale. So I am applying external forces on the scale. There are no changes in shape or size of the object. If the forces are withdrawn also, there are no changes in shape or size. So this objects can be treated as a rigid body for this amount of force. So when external forces are applied and forces have been withdrawn, if there are no changes in shape or size of an object, the object can be treated as a rigid body. Consider such a rigid body like this. This rigid body is making rotation about an axis xy with angular velocity omega. Now consider three small particles. Call this as particle number 1, particle number 2 and particle number 3 inside the rigid body. These particles are situated at different distances from the axis of rotation. The distances be represented as r1, r2 and r3. Let the particle number 1 has a mass m1 moving with instantaneous velocity v1. Particle 2 has a mass m2 moving with velocity v2, instantaneous velocity, and particle 3 be having mass m3 moving with velocity v3. Now let us write the linear momentum of particle 1, 2 and 3. So what is the linear momentum? Linear momentum of particle 1. The linear momentum is nothing but the product of mass and velocity. For particle 1, the linear momentum is given by m1 into v1. Similarly, this is the particle 1. Linear momentum for particle 2 is given by m2 into v2. The linear momentum of particle 3 is given by, this is nothing but m3 into v3. Now we know the linear momentum of particle 1, 2 and 3. Now let us determine the angular momentum of particle 1, 2, 3. So what is the angular momentum? The angular momentum of particle 1. Momentum of particle 1. The general expression for the angular momentum is given by mvr. For particle 1 is given by, which is equal to m is m1 into v1 into r1, right? Now we have a relation relating linear motion and angular motion. V is equal to r omega. So v1 is equal to what? r1 into omega. Instead of v1, I can write it as r1 into omega. So m1 into r1 into omega into r1. Product of r1 and r1 is given by r1 square. So the angular momentum of particle 1 is given by m1 into r1 square into omega. In a similar fashion, one can calculate angular momentum of particle 2. So in a similar way, the angular momentum of particle number 2, particle 2 is equal to m2 into r2 square omega. So in that case, we use the expression v2 is equal to r2 into omega. Similarly, the angular momentum of particle 3 is equal to m3 into r3 square into omega. Now we have calculated the angular momentum of individual particles. What is the angular momentum of the whole system? We have to add angular momentum of individual particles and infinite number of particles in which the system is made up of. So the angular momentum of the whole system, the angular momentum of system is equal to, see here, m1 into r1 square omega, this is angular momentum of particle number 1, plus m2 into r2 square omega plus m3 into r3 square omega plus so on. We are summing up all the angular momentum of individual particles. See, notice that omega can be taken as common. So this expression can be written as sigma, this is the summation mr square multiplied by omega. This angular momentum is represented by L. This sigma mr square is nothing but the moment of inertia. So L is equal to I into omega. L is equal to I into omega. So omega is the vector quantity, angular velocity. I is nothing but I is equal to sigma mr square. This is the inertia for rotation. This is the expression for the angular momentum of a system describing a rotational motion. Thank you.